create a new Xcode project, one of the options that we have is to use the game template. But using a template means that a lot of things will be automatically generated. I prefer to use this basic single view app so that you can understand exactly what is going on. So I'm going to call it game app, and my organization name is Deodus, organization identifier, net.optimist. Put your domain here in reverse, and then the language is going to be Swift. I do not want to include the unit test or the UI test. Click on next and then save that anyway. I'm going to save mine on the desktop, so click on create. The first thing we want to do is to go to the storyboard, and we have this view controller that has been added to the project. Every view controller comes with a UIView object attached to it. So what we want to do is we want to change the class of this UIView. We want to change it to an SKView. So select the identity inspector here and then just type SKView. Press enter to change the view from the UIView to an SKView. So once the class for the UIView has been changed to SKView, let's head over to the view controller, and then we want to import the class that we need, which is the SpriteKit framework. I'm going to delete the code here. I like to keep my codes clean, so I'm going to delete all these extra comments. Okay, so now inside the view did load, we want to cast the view to an SKView. So we're going to say let SKView equals to the view that we have currently, which is, as you can see here, it's a UIView. We want to change that view. We want to say cast as an SKView. If you do this without first changing the class of the view to an SKView on the storyboard using the identity inspector, then your app is going to crash. So make sure that you've changed the class and then you can cast it as an SKView. And then we now say SKView, the one that we just casted, dot present. So you can see that we can present a scene, but at the moment we do not have any scene to present. So the next thing that we need to do now is to create a scene. So let's right click on the game app folder here and choose a new file. We want to choose a Swift file. Click on next, and we're going to call this game scene. Okay, so create it. So now we have a new scene. For this game scene as well, I'm going to import SpriteKit. Then we want to create a class called GameScene, which is going to be a subclass of SKScene. Remember, we need to create an SKScene object. An SKScene object, whenever it's instantiated, the first function that is called the did move. So it has this did move. You can see that whenever this game scene move to an SKView, then here is where we're going to write a code. We can say self background color. We can change the background color to be red so that we can see exactly what is going on. Okay, so that's all I'm going to put here. I'm just going to change the background color so that we can see what is happening. Let me save this, go back to the view controller. Now that we have a scene, let's create a scene. Let game scene equals to game scene, and then we want to give it a size. So what's the size of our game scene? We want to be the exact same size of the view that we have, view dot bound dot size. Okay, so now that we have that, we can simply just plug that game scene here. So let's run our project now to see exactly what we've done so far. So as you can see, now the scene has been presented. Let me quickly recap exactly what we've done. What we've done here is changed the view that is added to our view controller. We've changed the class to an SKView, and by doing that, we also have to cast that view as an SKView here before we can use it. And then we use the SKView to present a scene, but we did not have a scene, so that's why we created a scene. And then here we created a scene which is a subclass of SKScene, and then we call the did move function. We override it, which is the first function that will be called whenever the SKView is trying to present a scene. Here we set the color to red. We can set it to any color. Let's change it to green. And then by having a scene, now we went back to the view controller, and then now we created a new scene with this game scene that we created and passed the same size so that we can have a full screen of the scene. That's why we use the size of the view that will present the game scene. So let's run it again. Here we can see that it's going to present the game scene and it should have a green color. If you have used the game template, you will not understand all these basics because Xcode will automatically create all of these game scene and write all these codes for you. This is why I thought it was important for me to show you how to do this without using the template. This is where we stopped previously. Now we want to add a cat image to the game. Where do you think we had it inside the view controller, or should we add it inside the game scene class? If you say the game scene class, then you're correct, because remember, every other children node that we're going to present has to live inside the SK scene. So this is where we're going to add the child node. So what I'll do is I'll delete this one that sets the background color, because we don't intend to do that, just to show you that the game scene was being called. That's why I changed the background color. So the next thing I'm going to do is to add image of a cat. So if we go to our asset catalog here and then bring up the finder, you can download it from the resources. So I'm going to drag the cat to the asset folder. So now I have the cat image there. Now let's go back to the game scene, and then we want to create a new node. We can say let cat node equals to SK sprite node. This is what we need to use, SK sprite node, and then it takes an image name, which is what makes it very convenient. It's very easy to add images to your app. So I'm going to call this, the image is called a cat, so that's what we're going to pass in. And then inside the did move, we can simply just say add child. This function, it adds a node to the end of the receiver's list of child nodes. So let's call that, and then we just want to add the cat node. By doing that, let's run our game to see exactly what it will display to us. So we have our cat here, but the full image is not showing. The reason why it is not showing the full image will be explained in the next lesson, because this is got to do with the coordinate system. But right now I just want to show you how to fix this problem. So what you want to do is, after you create the node, we can change some of the properties. So the first property we're going to change is called the anchor point. So I'm going to say cat node dot anchor point, and I want to change the anchor point to a CG point of 0. So if you say CG point dot 0, this will be explained in the next lesson, so don't worry about it, just do it. And then if we run the app now, we will see that the cat full image will show. Now that we have changed the anchor point, we can see the full image of the cat. Another function that I want to introduce you to is the set scale. So if I say cat node dot set scale, I can pass in any value to either reduce or increase the size of the cat. So what I can do is I can say 0.5, which means the cat is going to show just 0.5 of the size of the original image. So it's going to scale it down. So let's look at that. You can see we have a smaller cat. And if I change this to 2.0, then we're going to have the twice the size of the original image size. So this scale, just as the name says, it scales the node. So we have twice the size. So I just want to call your attention to this valuable property that we're going to be explaining in the next video, and then the set scale function. Another thing I should quickly mention before I go is the properties of the SKView itself. So SKView has two important properties that you should always use, just so that you can see what is going on with your game. The first one is called the show FPS. So let's say SKView.show FPS. This is a boolean value that indicates whether the view displayed a frame rate indicator. So let's set that to true. And then the next one, which is also important, is SKView.show node count. So you want to see how many nodes is running. So I'm going to also set this to true. When we run the app, this is going to show us the FPS information, so you can see the frame per second. Right now it says we have 2 nodes. You can see at the bottom here it says node 2, and the frame per second is 1 FPS. We don't have any action going on, so Don't worry about the frame per seconds, but at least here it says 2 nodes. Why does it say 2 nodes when we only have a cat? The reason it says 2 nodes is because an SK scene is also a node. For example, if I command click on this SK scene and jump to definition, you can see that the scene itself is also a subclass of an SK node. You can see that SK scene is an SK effects node. If I command click on SK effects node, jump to definition, you can see that SK effects node is basically an SK node. This is why I say on the simulator that we have 2 nodes, because we have the cat and then we have the actual scene running. So this is why we say the scene is the root node, and then it can present other nodes such as cat, bomb, car, dogs, and so on and so forth. So I hope this makes everything even more clear. So let's take a look at a couple of images. If you're using the UIKit framework, you know that the coordinate system starts from the top left. So the X progress as you move towards right. So X is 0 at this point. Then X becomes 1, 2, 10, 20, 200 as you progress towards the right. And then your Y increases as you go down on the UIKit framework. So the top left corner is the starting position, 0, 0. However, on the SpriteKit framework, it is completely different. You have the origin at the bottom left. So the X increases as you go towards the right, which is still the same as on UIKit. However, the Y increases as you go up. Here, the Y increases as you go down, but here, the Y increases as you go up. So keep this in mind. The bottom left is the 0, 0 point. Anything you place at point 0, 0 of the coordinate system will go to the bottom left. And this is why the cat was stuck around the corner here. So the next image we're going to look at is here. Let's say we have this SpriteKit game here. You can see that the coordinate is at the bottom here. And then we have an SK sprite node. So two things that I'm talking about here is the scene, which is the blue screen that you see here. So these are the scenes. The black one is an SK sprite node. Keep that in mind. So the scene here has its coordinate at the bottom left, 0, 0. Okay, I already explained that. And then a node has an anchor point in the center. So right now, the SK node by default has something called an anchor point at its center. So this is why when I added the cat earlier on in the previous app, you can see that the anchor point, because I did not change the anchor point, it was in the center of the rectangle or the square, it automatically matches itself with the bottom left, which is the point 0, 0. So because of that, I only saw a part of the cat. So let me explain again. The anchor point is in the center of the node. Then if I should add that node to the scene, the anchor point, by not changing it, will automatically default to the coordinate at the bottom here. So that is why we saw only a part of the cat. So what I did was to change the anchor point. By moving the anchor point from the center, I moved it to CG point dot 0. So that means I also move it to the bottom left of the node. So I move the point from here, from the center, I move it here to the point 0. Remember that even an SK scene is a node. So every node have its origin here. So that's why I set the anchor point to be CG point dot 0, which is also the bottom left. And then if I should do that, so here, positioning the node using the default anchor point, which is at the center. So this is what it looks like. That's why we have half of the cat showing, or a quarter of the cat showing. But here, I changed the anchor point to the bottom left, which is the CG point 0, to match the scene. So by now changing the anchor point, that means the anchor point and the coordinate point, which is the origin of the SK scene, they're going to match. So that is why we eventually saw the full cat. Okay, then here I'm changing the position. So the anchor point of the node has been changed to 0, 0, and its position in the scene also changed. So here now what I've done is, instead of accepting the default position, there are two properties of any node that you can change. You can change the anchor point, where here I've changed the anchor point to the origin, the CG point of 0, and then I change the position so that the X starts at a different value and the Y starts at a different value. So let me go to Xcode project to explain this by code. What I'll do is I'll quickly create a new coordinates. Let me see if that's going to make more sense to you. Okay, so import SpriteKit, and then here I want to say class coordinate, and it's going to be SKScene. Okay, and then just to demonstrate this properly, I have another image called squares, so I'm going to go to the asset folder again, and then let me bring up and I'm going to drag this square here. Okay, so now let's go back to the coordinates. Then we can say let square equals to SKSprite node, and then we want to pass the image name. It's called squares, and then we need the did move. Remember, if I should say had child, and then I pass the square child I just created in there. So now that we have a new scene, we need to present that scene using our SKView. So instead of presenting the game scene, let's create another scene. Let coordinates equals to coordinates, and then we want to pass the same size, which is the view.bounds.size, and then we're going to present the coordinate scene here rather than the game scene. So if I should run this app, what do you think should show? If you said, let's go back to our asset catalog, you can see that because I didn't change any property of the node, so that means the center, let's watch what's going to happen. You see that only a quarter are shown, and the reason is because the anchor point is in the center. So by being in the center, that means this part will be on the left edge. We're not going to see it. We're not going to see this one as well. So only this part is going to be showing. So what I'll do next is now to change the anchor point. So let's change the anchor point. Let's go there, and then we want to change anchor point. We want to say square dot anchor point. So now we want to change the anchor point to be CG point dot 0, which means we're moving the anchor point from the center to the bottom left. So that means it's going to position itself. The bottom left and the bottom left are going to align. So that means it's going to show this. So that means the anchor point is here. Previously it was in this center, so that's why it's only showing here, because the center aligned with the point 0, here. But if you want to change the position so that we don't have the point 0 as the coordinate, we can change the coordinate. All we need to do is say square dot position equals to CG point, and they want to give it an X and a Y value. So let's say the X start at 40 and the Y start at 60. So let's run that. So that means it's going to shift it towards the right and then up. So you can see that our app has been shifted towards the right and then up. Well, what we can also do is we can move it down if you want to. We can say -20, for example. So that means it's going to move it down. It's going to move it right and then down. So you can change the position however you want. You can change anchor point. The anchor point might be slightly confusing. This doesn't show much. Let me move it by say -50 so that you can see more effect. The anchor point can be slightly confusing. The coordinates might be confusing, but as we progress in the course, everything is going to make more sense to you. You can see that it's moved it down and it's moved it towards the right. What we can do is we can change the color of the coordinates. So we can say here self dot background color equals to dot yellow, and let's see what happened. This will give you a better idea of exactly how much it has moved from its original position. So you can see that this has moved 20 points or 40 points towards the right, and then it moved down. So this is how you change the anchor point and the position, which is the coordinates of SKSprite node. So what I'll do is I'm going to go back to in fact, I'm going to delete the coordinates because it's not really relevant to our game. Just use that to learn. So let me go back to the view controller and delete this particular coordinate so that we can go back to where we were. Right now we only have one node inside the game scene. So I want to add another node, so which is going to be the background of our app. So if I should run the app now, we shouldn't have any color in the background because something is missing. Right. Let's go to the view controller. Okay, yes, we have to present the game scene, not the coordinates. Okay, so if I should run the app, we should have a black background. So as you can see, we have the black background for the app. So what I want to do is I want to change this background to the image that I have. So again, let me go back to the asset. I'm going to delete this square as well since it's not relevant to our game. And I'm going to bring back the finder and drag the background that we have here, which I'm going to change the name to BG, just the background. Okay, so now go back to the game scene. I want to add a new node. So let BG node equals to SK sprite node, image named, and the image is called BG. Okay, so now let's add this. We're going to say BG node dot anchor point equals to CG point dot 0, and then we're going to say add child, and then we're going to put the BG node. So let's run our app and see how that looks. As you can see, now we have 3 nodes, which is the background, the cat, and the scene itself. So what will happen if I should put the background, so if I should add the background after the cat. So let's see what happens if I should do this. So now I'm adding the background node after I had the cat node. So let's see what happens. We will not see the cat, and the reason we will not see the cat is because the cat is behind the background. The Z or Z position, however you want to call it, allow us to lay out our view so that we can have one node above the node. The lower the Z position number, then that means that will be at the bottom. So if I should set the BG, if I should say the BG node dot Z position, and I set that to 0, and then set the cat node dot Z position, and I set that to 1. So that means this, it doesn't matter now if I had this one first or if I had that one second. The fact that the Z position is used to render it, that means the background will always be at the bottom of the cat. Anytime you want to arrange your view, you want to set which node is above another node, then you have to use the Z position to do that. The greater the number, the higher the node is going to be. The node with a lower value will be at the bottom. So right here, the background is at the bottom because the value is 0, and the cat node is at the top because the value is 1. So if I want to place a cup on top of this cat now, then I have to put the Z position to 2 so that it can be above it. I hope that makes sense. So this is how you use this Z position to determine how your nodes should be placed relative to the view. This is where we stopped last time. What we want to implement is a function called touchMoved that will allow us to detect the current location on the screen where we touched and to move our object to that location. So what you want to do is outside the didMove function, you want to call a new function called touchMoved. Tells the responder when one or more touches associated with an event changed. Select this function, and inside this function, let me get more space at the bottom here. Inside this function, you can see that it passes to us an array of set of touches. So you have an array which is a set of UI touch. So we want to get the first of the array. So what we do is we say let touch equals to touches dot first. So we can get the first one of the collection, and then once we have the one of the touches, which is the first touch in the collection, we can get a location inside of this view. Then we can say let location equals to touch dot location. You can see that it returns a location in SK node, and we know that our scene is an SK node. We already looked at that in the past. So here it says returns the current location of the receiver in the coordinate system of the given node. So if we select this and then we pass in self, because our scene is an SK node, so we pass in self, so it's going to return the coordinate system of the location that was touched. But this location is an optional, so we need to unwrap it. So we have to say if let, and then we have to then use it inside the if let statement. We can then, what we're trying to achieve, let me bring up the simulator so that you can see what we're trying to achieve. What we're trying to achieve is, right now the cat is stuck in this location. We don't want to change the Y value, because remember, every time we change the Y value, increase or decrease it, it moves up or down. So what we want to do is change only the X value. So if I touch a new location, I want to move the X value of the cat to that location. If I touch here, I want to move the X value of the cat to the new X value of the location. So what we do, we say cat node dot position dot X. So we want to change only the X position equals to location dot X. So that means we'll move the cat node position X value to the location X. So let's see how that works. So now you can see that every time I click on a new location, the X value of the cat changes. I can also drag the cat. You can see that I can drag it because the touch is moving on the screen. And every time I move my touch, the cat is moving along because the X value of the cat changes. So this is how you use the touch move function to change the X or Y position of your SK sprite node. What I want to do is to quickly clean up this code. So let's write a couple of functions. I'm going to say func, and then I'm going to say add cat, and then I'm going to copy the cat node code. So I'm going to paste it inside the function just to make the code more cleaner. So now let's call the add cat inside the did move function, and then we're going to create another function called add background. Copy this code and then paste that code here, and then we can call add background here. So now our did move function is looking a lot cleaner. So the next function we want to add is to add a ball onto our scene. So what we do is we create a new function. We're going to say add ball, and so before we forget, let's add the ball function inside the did move so that we don't forget to call it. And then we also want to add a new asset. So I'm going to bring up my finder and then drag this red ball onto the asset catalog here. So it's called red ball. Now let's go back to our scene, and then we want to add the ball. So let ball equals to SK sprite node and image named red ball. If you don't type the correct image name, then it's not going to work, so make sure you type it correctly. And then the key thing is we want to, let me bring up the simulator. We want the ball to drop from the top here. So we want the ball to start from the center at the top here and then come down. So we want to add an action to make the ball drops down. So in order to do that, let's think about the value that we need, where we're going to position the ball. We know that at the bottom here is 0, 0. So that means when we go from 0, 0, if we go up, the Y increases. So that means we need a value to be exact height of our game screen. So the scene that we have, we want the value of Y to be the exact height. The value of Y goes from bottom to top. So we need the exact value of the full height of Y. So we want Y to be the exact full height of the size of our scene. However, we want the X value to be just here, which is the midpoint. So that means we want the X value to be the half of the width. So we want the Y value to be the full height, and then we want the X value to be half of the width. So let's try and do that. We're going to say ball dot position equals to CG point, and then we can create a CG point with this value. So our X is going to be self dot size dot width divided by 2. It's going to be half of the width, but it's going to be the full height. So then the Y is going to be self dot size dot height. Okay, so once we do that, we can say add child. We can add the ball to the, let's run this and then see how that looks first. As you can see, the ball has been placed at the top here and in the middle exactly where we want it. Let's add the set scale function to reduce the size. So I'm going to set ball dot set scale, and I'm going to set that to just 0.3 of the value. So I just want the 30% of the current size. You can see now we have a small ball at the top exactly how I want it. So you can set this to any size that you want, but I'm quite happy with the way it is. So the next thing we want to do now is to add an XK action so that this ball can drop from the top to the bottom. So let's add that here. I'm going to say let move action equals to XK action. And this XK action has a lot of class methods. If you click on dot, you can see a lot of things that we can call on it. But the one we need, it says move to Y. The reason why we need a move to Y is because remember, if we say move to X, X is an horizontal direction, Y is the vertical direction. So we want to move it to another point Y. So every time we go in the vertical direction, is the value of Y that changed, not the value of X. So we need one that to say move to, you can see this one say move to Y. So create an action that moves a node vertically. So let's select that. So which Y value do we want to move the ball to? So if you think about it, our ball starts from the maximum value of Y, which is the height. Now we want to move it down to say when Y equals to 0, which is going to be at the bottom here. So we're going to move it to when Y is equals to 0. And how long do we want that action to take? I'm going to just put a value of 5. Okay, so once you create an action, so we've created an action, now we have to run the action on an XK node. So we can say ball, then you say run action. You can see it will add the action that we create to that node. So let me select that and now say move action. So I want to run the move action on the ball. So let's see how that works. So the ball is added to the top and then it drops to the bottom. So this is how simple it is to add an XK action to our game. This is where we stopped the last time. What I want to do is I want to quickly create a touch began function, the one I showed you earlier on. So in this touch began, what I'm going to do is whenever there is a new touches on the screen, I'm just going to call the add ball. That's what I'm going to do, so that every time I touch the screen, there's a new ball that is created and then move down. So I want to use this function to show you that you need to be careful when you're creating your game to make sure that every time you create a sprite node, if you don't need it, then you have to remove it from your screen. So right now you can see that we have 4 nodes at the bottom here. So if I should click on this, you can see that a new ball is dropped, and I'm going to click again. You can see that a new ball is created. Now we have 6 nodes. Click again, we have 7 nodes. And the reason why it doesn't look like we have is because they're all on top of each other as soon as they get to the position of Y equals to 0. So we have 8 nodes, and then you can see that our FPS is going to keep dropping the frame per second. It will keep dropping the more, just pay attention to the frame per second. So you can see that it will keep dropping the more frames that we have, the more nodes. We have 38 nodes now. This is not a good thing. So you have to remove the nodes that you don't need from. So if you have any sprite created, now we have about 35 sprites here on our screen that we don't need, but we're not removing it. So what we're going to do is we're going to create a delete action. So delete action. So let's go back to where we add the ball. Before I run the move action, I'm going to create another action. I'm going to say let delete action equals to XK action, and then this time I want to remove from parent. So this is an XK action. It creates an XK action that removes the node from its parent. That's what we need. And now that we have 2 actions, how do we run it? We do not use the one that say run one single XK action. We have another run function that will take a sequence. If I say run action and I select that, and then I say XK action dot sequence, the sequence takes an array of different action, and it's also an XK action. So this sequence function is an XK action, but it takes an array of other XK actions. So I'm going to select this and I'm going to pass an array that we need. So that means we are going to run the move action first, and then when the move action completes, that means the ball is at the bottom, then we're going to run the delete action. So it's going to run 2 actions. It's going to run on every ball that is being created. It's going to move it to the Y value of 0. And then when that action is completed, then it's going to also run the delete action, which means it's going to remove it from its parent. So let's run this and then see how that works. So watch, here's a 4 node. As soon as it gets to the bottom, it's going to remove it. You can see now it becomes 3. So if I keep dropping new balls, they will be created, but they will be removed as soon as they get to the bottom. So we are never having more than the number of nodes that we need. So you should always keep this in mind. You should always use the delete from parent action if you don't need the nodes to hang around. So it doesn't matter how many nodes I add now, as soon as they get to the bottom, they will be removed. So here we've created multiple action, and then here we've used the SKAction sequence function to run as many actions as we need. If you want to scale the sprite before we remove it, we can just say let scale action equals to SKAction dot scale by, let's say 0.5, and then duration, let's just give it 1, and then we can add the scale action. So move, scale, and then delete. So let's run this and see how that works. So it's dropping it, and then it will scale it, and then it's going to delete it. You see that? It scale it and then delete it. Now we've created multiple actions, so it will drop it, it will scale it to 0.5 of the size, and then remove it. Even though we don't need it, just to show you exactly how to create multiple actions and how to run those actions in sequence. Here is where we stopped the last time. Currently, what we do is we're using the touch begin to create a new ball. So every time we touch the screen, we add a new ball, but that's not how the final app is going to function. So I'm going to remove that. What we want to do is we want to use a timer function to periodically, so every 1 second or 2 seconds, or we can even pass a random second, so that we can say each ball drops, say one drops after 1 second, another one drops after 2 seconds. But I'm going to keep it simple. I'm just going to call the timer every 1 second so that we get a new ball drop from the top to the bottom every 1 second. So the first thing we want to do is we want to create a timer variable that we can change. So we can say var timer, and then let's just initialize it to be a timer. Here it says a timer that fires after a certain time interval, and then we're going to initialize it. So inside the did move function, as soon as the did move is called, I want to initialize the, in fact, I will not call this one here again hardball, because I'm going to use the timer to call it. You can see the timer object equals to timer, which is the class, dot, then we want to schedule or schedule, however you want to call it, and then we need this third one that creates a timer and schedules it on the current loop in the default mode. So let's select that, and then what is the time interval that we need? Here I'm going to pass in 1 second, and then the target is going to be the self, we're going to be the one calling it, and then the selector, which functions do we want to call every 1 second? Here I'm going to say the selector, and I'm going to pass in the add ball function, add ball. So that's the function we want to call. User info, this is if you want to pass in some other information. We don't need anything, so here it's just going to be a new. Repeats, yes, of course, we want to repeat it every second. If you don't make this to be true, then you're just going to call it once. So make sure that repeats is set to true. We have a problem here because every time you use this selector with the pound sign, it's going to add the @Objective-C to your function. So let's just click on fix, and the changes it's going to make, it's just going to add the Objective-C keyword at the back of the function when you use the selector. And I think that's all we need to run our app. So let's run the app to see exactly how that works. So the ball is dropping every second, and this is really fast. Maybe we want to change that to, let's change that to 2 seconds and see how that works, because the 1 second is slightly too fast. Let's try 2 seconds. Okay, so it's dropping, and then 2 seconds after, another one is going to drop, and every 2 seconds we're going to have a new ball, and then we can use the cat to, deal with the ball that is being dropped from the top. So this is how you use the timer to call a function that will repeat itself at the time value that you set. You can use this in your app to, for example, if you have different sprites that you want to drop from the top or from a corner, you can use a different timer to manage that. So in the function where we add the ball, currently the ball position is fixed, so I'd want to change that. What I would do is I would just set the ball.position.y. That is going to be a fixed value, so let's set that to the value that we set here, which is the self.size.height, self.size.height. So the position of y will not change, but the position of x is the one that we want to randomize. So in order to do that, let's create a random number. There is a function called the arc for random uniform that we can use to create. So let me show you how that works. So if we select random x, there's this arc for random. So if you type arc4, you can see it has various functions that we can use. The one that we need is this one, which is the arc for random uniform. What this function does is it will take an upper bound. So let's say we want to generate a number between 0 and 10. So our upper bound will be 10. So what we want to do is we want to pass the maximum value we need here, which is going to be self dot size dot width. So we want to generate a value within 0 and the maximum width. So let's say our screen width is 320 points. So it goes from 0 to, so our x value goes from 0 to 320 points. So that means this value will generate a random number within that value between 0 and 320, and then we can use that value for our x. Because our width is of type float, it needs to do the conversion. So let's do that so that we can typecast it. So now what we need to do now is to say the ball dot position dot x equals to this random x, and then again, because our position dot x is looking for a CG float and this is the uint32, we need to do the casting back. Okay, that's done. We just need to click few buttons to do the casting. If we run the code now, this is not totally correct way to do it, because it means that sometimes the ball might not appear on the screen. It might go to the edge because we're setting 0 and we're setting the maximum value. We need to do some subtraction and addition, but you can see that the basic one is working okay. I don't want to make it too complex, but you can see that this is actually working quite good. So you can see that the ball is being sent down from a different x position because we randomize the value of the width. We're getting the value between 0 and the maximum width. So our game is looking quite good and I'm quite happy with what we have so far. So let's continue with building our game. This is where we stopped the last time. The next thing that we want to do is to create a new scene. Right click on the game app and select new file. You want to select the Swift file, click on next, and then we want to call this one the start scene. Click on create to create a new scene. Here we want to import the SpriteKit and not the foundation, and then we want to create a class called start scene, which is going to be a subclass of SKScene, and we also want to override the did move function. The first thing we want to add is a button that we need to start the game. I'm going to go to the assets folder and then bring up the finder. I'm going to drag this button called start. I'm going to drag it here. Now go back to the start scene. I'm going to create a play button SK sprite node. Let play button equal to SK sprite node, image named. We've done this a couple of times. The button is called start. So now we want to place it on our screen. So let me set the position of the play button. I'm going to say play button dot position equals to CG point, and we need an X and Y value. So the X value I'm going to set will be half of the width and then the quarter of the height, because I want to place it towards the bottom. Self dot size dot width divided by 2, and then self dot size dot height divided by 4. And then let's add the play button, our child play button. Before we can see this in action, we need to go to the view controller. We want to change the starting point of our game to be the start scene and not the game scene. So let start scene equals to, so I'm going to change this to the new scene that we just created. So now I'm going to copy this so that when we present from the SKView, we present in the start screen. So if I should launch the app now, we should be able to see the button that we just added, which is the play button, and that should be towards the bottom. However, we might need to set a couple of more properties such as the scale and the background color. Right now the background color is black by default and the button is bigger than I need. So let's go back to the start scene and I'm going to change a couple of property. Play button dot set scale, and that will be 0.5. I want half of the size, and then I want to change the background color of the view. Self dot background color equals to, by the way, there's a SK color that we can use, dot white, rather than the UI color. So keep that in mind, and I'm going to run it. So instead of using the UI color the white, you can say SK color the white, because that's more for the SK class, which is the SpriteKit class. So this is looking more like exactly what I want. So I'm going to create a new sprite node. Let cat node equals to SK sprite node, and I know we called it cat. And then here I'm going to say cat node dot position equals to, I'm going to use the same CG point as the button because it's going to be in the center, but the only thing that will be different is instead of placing it close towards the bottom, remember as we move up, the Y value increases. So instead of dividing it by 4, which is just quarter of the height, that's where I place the button, I want to place it towards the top. So I'm going to multiply this by 3/4. Okay. So let's see what that looks like. We need to add it first before we can run the code. Add cat node. So let's run that. Okay, so that looks great. You can see that if we should divide the Y value by 4, 1, 2, 3, 4, you can see that the button is placed just exactly quarter of the height. And then we move out 3 times, the cat is placed towards that. So if we should choose another simulator, for example, iPhone X, I'll run it on that as well. The position should be the same. So this is how it looks on both the iPhone X and the iPhone 8 Plus. As you can see, the positioning is quite correct. The best way to position your sprite node is to kind of use a fraction of the width and height so that the placement can be correct in any screen size that you choose. Anchor point values have this unique 9 coordinates. At first it might seem very confusing, but they're actually quite straightforward. If you think about it, here X and Y value is 0, but as you move towards the right, the value of X increases. So that means in the medium point here, X is 0.5, then X is finally becoming 1. Here as well, in the midpoint, X is 0.5, here X is 0.5. So as you move towards the right, X value is increasing. For Y, as you move up, the value of Y increases. So that means here Y is 0, and then Y becomes 0.5, and then Y becomes 1. X here is 1, X is 1, X is 1. So this value is actually quite straightforward. So the midpoint is 0.5, 0.5. So if you change your anchor point to 0.5, 0.5, it means you're moving the anchor point from this corner, you're moving it to this, to the mid center. Also, if you change your anchor point to 1, 1, it means you're moving your anchor point from the bottom left to the top right here. So as you can see, it's a quite straightforward values. I'm going to show you in code how to place a particular small rectangle, and then we're going to use it to cover half of the screen like this. So let's think about, this is the screen of our game, and then we have a very small rectangle. By default, the anchor point is 0, 0 for the screen, and it's also 0, 0 for the sprite. So then I'm going to change the anchor point of that sprite. I'm going to change it to the value at the top here, which is 0, 1. So by changing it to 0, 1, the anchor point will move to the top left. And then I'm going to set the position on the sprite. So the first thing I do is to change the anchor point, and then I'm going to set the position. The position is going to be X, where X is going to be 0 and Y is going to be half of the height. Remember, the value at this position is half of the height for Y position, and for X is still 0 because we haven't moved anywhere. So that means by setting the position to X equals to 0, Y equals to half of the screen, the small rectangle will move to this position. And then by setting the size, I'm going to set the size where I'm going to set the width to the entire width of the screen and height to just half of the height of the screen, and it's going to cover the half of the screen. So think about it, pause this video, watch it again. The default position, change the anchor point. After changing the anchor point, position the sprite to this position and then change the size. This is how we're going to set a small rectangle to fill half of our screen. Let me now go to Xcode to demonstrate this by code. Now we're back on Xcode. I need to go to my asset folder. We're going to be using the small square, so I'm going to drag it here. It's called square. Now let me go back to my start screen and then add that. Let square node equals to sk sprite node image named square. So the first thing we need to do is to change the anchor point of the square node. Square node dot anchor point equals to cg point, and here we want to change it to 0 1. 0 x will be 0 and y equals to 1. And by changing that, now the next thing we want to do, we want to position it. So I'm going to say square node dot position, and that will be cg point. X will be 0, and then y will be self dot size dot height divided by 2. So by doing this, I can already add the square node. Let me add the square node so that we can see exactly what we have currently, just exactly as I showed you previously. So right now it's just going to be a small square floating somewhere on the left midpoint of our screen. As you can see, if I want to cover the entire bottom of the screen, I just need to set the size. So I'm going to say square node dot size equals to cg size, and this one will allow me to set the width and the height, and then the width I want to set will be self dot size dot width, and then the height self dot size dot height divided by 2. So by doing this, we'll be able to cover the entire bottom half of our screen. This is not the only way to do it. In fact, you can place the anchor point at the top right as well if you so wish. And as you can see, now this is looking real good, exactly as I want it. So I just want to show you a little bit more information about anchor point. Go through the anchor point to see how you can manipulate the anchor point. In fact, if we have put the anchor point at the top right as well, we could have done the same thing and it's still going to be worked, because if I set the anchor point here and I position it, instead of position it here, if I position it here, then I can still set the width and the height. But go ahead and play around with the anchor point and the positioning. That will allow you to learn more about how to use the anchor points. I just want to quickly show you how I created the images that I'm going to be using for the animation. So what I did was to use the canva.com website. I always use this website for simple basic image manipulation. So what I did was to create a design of 400 pixel by 400 pixel and then add the cat image. So after uploading the cat image, what I did was now to start rotating by using this handle. So I can use this handle to rotate my image. So you can see that I was rotating the image. So here I was rotating it anti-clockwise, then now back to clockwise, back to the original image, then now rotating it clockwise even more, and then now return it back again. So now I have about 12 images. This may not be the best animation images ever, but it will work for what exactly we needed it for, just to show you. So if you have any animation images that you want to use, then I will show you how to use the SKTexture class to animate that images. So let's go to Xcode to learn how to use this. Before we can animate our image, we need to bring that image to the folder. So let me bring up the finder and then drag this one that says cats images. So I'm going to drag the cats images here. So you can see that the cat images have 12 images in it. So now let's return to the start scene. So the first thing we want to do is to create an array of SKTexture class. So let texture is equals to array of SKTexture. So what we need to do next is to now add our images to this array of SKTexture, and we can say texture dot append, and then if we want to append an SKTexture, and it also takes an image of image name. So we know our image is named from 1 to 12. We need to change this to variable because we need to append values. So we can either do this, which is not efficient. We can say 1, 2, 3, and so on and so forth. Or we can simply use an array. I mean, this is the perfect way to use an array. So we can say for I in 1 dot 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 12. So then we can say texture dot append. So we want to append all our elements, and so that will be sk texture, and then text image named, pass in the I. If you know your for loop, we're simply going through the 12 images and then we're appending all the images in this texture array. Once we have all the images texture added to the texture array, then the next thing is we need to create an animate action. Let's create action. Let animate action equals to sk action dot animate. It has this function called animate, which takes an XK texture and then you specify a time frame of how long it should repeat it. So I'm going to select it. I'm going to pass the texture that we already have, and the time frame I'm going to say 0.1 seconds because I want the animation to be fast. And then once we create the animation action, then we need to run the action, right? You know that we always have to run the action. So then we have to say the cat node dot run action. The action that we want to run is an SK action that repeats itself. So we have to say repeat. There's this one I call repeat forever, and it will take an SK action. So the SK action that we want to repeat forever is the animate action that we created above. So let's go through that again. We're running this cat node. We want to run an SK action, which we want to repeat forever. There is another repeat function that will repeat for certain, so you can say repeat 30 times, but we need the one that say repeat forever. So let's run this and see what we have. If we're lucky, we should have the animation running on the screen if there's no bug. So you can see we have an animation going from left to right, right to left, which looks quite good. So let's repeat the process again. We created an array, a variable of sk texture array, and then we added all the images that we have from 1 to 12 by using this for loop. And then we created an sk action that will animate, which take a texture and you set the time frame. If we set this, for example, 0.5, it will be slower. And then we use the node that we need to run the action and repeat it forever. So let's run this, setting the time frame to 0.5. That should be a slow animation. See, that one is quite slow. Animation is, I don't like the slow. I like it to be fast. So let's set it back to 0.1. And this is how you animate any images that you have. If you have multiple images, you can run animation on them. I hope you find that useful. Right now in our game, when we click on the start game, we are not able to transition to other screen. So we want to be able to detect when a user click on the start game button. So the function that we're going to use for that is called the touches begin, which we already looked at in the past. So let's override the touches begin function, and then we've already learned how to detect a touch, which is going to be touches the first. So we're going to take the first of the touches in the array of touches, and then we're going to get the location. If let location equals to touch dot location in this sk node, which is going to be a cell. So now once we have the location, there is a particular function called at point. So let me show you. If we say if at point is a function, you can see that this function is say it returns the deepest visible descendant that intersects a point. So we want to check which SK node. You can see that it will return an SK node to us. We know that an SK scene is an SK node, an SK sprite node is also an SK node. So it will return to us which SK node is at the point where we touch. So if I select this function and then I pass in the location, so we want to know which SK node is at the point, is at this CG point that we touched, and we want to compare that to the play button that we created. So we want to say if the node that is returned at this point that we touch, if it's the same as the play button, this is when we want to perform an action. So let's just print something. Let's just print clicked, and then let's run the game to see if that works, if this print statement is executed. I am going to click on different area of the screen. So I'm going to click on the cat, nothing's happening. Click here, nothing happens. But if I should click on the start game, you can see that I say clicked because the point that we touched intersect the start game. So that means it's working. So we need to transition to the gameplay screen. We already know how to do that. So let's create a scene. Let game scene equals to game scene, which is the class, and then we want to give it a size, and the size we want to give it is still the self.size, so the size of this particular scene as well. And then how do we present it? We can say self.view, because this particular scene will have the SKView, the view that is currently presenting the scene, and then we want to use that to present the scene. So game scene. No, not the class. We're not presenting the class. We're presenting the actual object of the class. So let's run this and see if that works. So if I click on start, you can see that it takes us exactly to the game scene. So that means our function is working correctly. But the only thing I don't like is because it's very abrupt. It's very quick. There is no animation. There is no transition. It was just taking us straight to the screen. So this is where we're going to find it useful to use a transition. So let's create an SK transition. So let transition equals to SK transition. This SK transition also has lots of class function. We can say dot. As soon as you put dot, you can see we have so many transitions we can use. We have crossfade, door closes horizontal, door closes vertical. Let's select this one that says does close vertical. The time interval represents how long do you want the transition to take. So I'm going to say I want mine to take, say, 2 seconds. Let's say 1.5 seconds. And then the good thing is the present scene. Let's use this present scene. It takes a transition as well. At the moment, we're just using the one that doesn't take a transition. There is an option that also takes a transition. So let's select that. So I'm going to pass the game scene, and then I'm going to pass in the transition that we create as well. You can play around with the different types of SK transition that you want to use. There's so many options. You can use fade, you can use door closes vertical, you can use flip, you can use rotate. There's so many. So if I click on the start game, you can see that the door just closes on it. Let's select something else, and let's say doors open vertical, open horizontal. Let's try that. 1.5. Start game. You can see the door opens vertical. So shall we select fade, SK transition dot crossfade with duration. Let's try that. 1.5. Play around with the transition and see exactly which one you like. Play game. There you go. What we've learned so far is we created a location, which is the CG point the user touch. Then we find the SK node that is at that point where the user touch, and then we compare it to our play button if it's the same. If the SK node that was returned is the same as our button, and then we perform actions, which is to create a new game scene, present the game scene with transition. Similar to what we did for the start scene, we're going to create a end game scene as well. So right click on the game app folder and click on new file. Here we want to select Swift file, and we want to call this game over scene, and then click on create. We want to import the SpriteKit, and then we want to create a new class called game over scene. It's going to be SK scene subclass, and we want to override did. I'm going to quickly go to the start game scene, and I'm going to copy some code, because we need the same code in the game over scene. So we need to play so that when the game is over, the user can start again. And let's position. So the same positioning that we have for the play button, we're going to use the same positioning for the game over inside the did move. And same thing, we need the touch begin function that we created in the last video. We need that as well, so that when the user click on the button, the play button, the user can transition back to playing the game again. So all of these codes are the same, so there's no point for me to waste time writing them all over again. The only thing I want to call attention to is something called the SK label node. The SK label node allows you to write simple text on your screen, because right now so far we've only been using images. So if you want to write a simple text, just like the UI label in UIKit, the SK label is in the SpriteKit. So let's create one. Let game over label equals to SK label node, and as soon as you open the brackets, you can see that we have one option here that will take a default text as a string. So here I'm going to call this one game over, and you can set some of the properties which I'm going to set inside the did move. So I'm going to set the first one I'm going to set is the font color. So I'm going to say game over label dot font color, and I will set that to SK color dot white, and I want to set the game over label dot font name. I'm going to set that to Helvetica, and then game over label dot font size, I'm going to set that to 40. So as you can see, this is not different from using the UI label in UIKit. Okay, and I'm going to set the positioning, which is important. The position equals to CG point, and here I'm going to place it at the center, vertical and horizontal center. So in fact, I can simply just copy this. Let me copy this CG point, place that here, and I'm going to make this one a 2, so it be half of the height and half of the width. And then finally, we have to add the game over label. Right now, we do not have any event that will allow us to present the game over scene. In the next video, we're going to be creating an event that will allow us to present the game over scene so that we can see all the things that we created in this video. Right now, we have our timer function, which is been calling this every 2 seconds. So I'm going to change this to 1 second, and then I'm going to create a new variable that will track the game time. It's going to be an integer. It's going to start from 0. So what we want to do is every time the this scheduled time calls the add, remember it calls it every 1 second. So every time you call it, I'm going to increase the game time by 1. So I'm going to say game time plus equals to 1. So I'm going to add 1 to the value, and then I'm going to check if game time is greater than 10. So this is the time I want to perform certain action. The first thing I want to do is I want to invalidate the timer. So every time you have a timer and then you want to transition, make sure that you invalidate it, so this would stop the timer from firing again. After invalidating the timer, and then I'm going to present the game over scene. Let's quickly create a function that will present game over scene. Okay, so what I want to do is just say let game over scene equals to game over scene, and then it's going to take a size which will be self dot size, and then we want to create a transition equals to sk transition, and then dot, let's just choose 1.5, and then we will now want to present this game over scene. We're going to say self dot view, which is going to give us the SKView dot present. So we want to present with transition game over scene, and the transition will be transition. Okay, that's all we need. Then we need to call this function inside this if statement. So if the game time is greater than 10, then we want to invalidate the timer, and then we want to present the game over scene. So let's run it to see exactly how the game over scene looks, because we haven't even had the chance to look at it even though we created it. So let's start the game, which is going to launch us to the game, and then every 1 second the ball is dropping, and then after 10 seconds we should have game scene presented to us, game over scene. There you go. So this is the text that we wrote previously, which says game over, and then we can change the background. Let's change the background to some color. What should we use? Game over scene. Let's change the background self. Background color equals to dot orange. Shall we try dot orange? And let's try that. Let's see what it looks like. We have a lot of orange colors in our game already. Start game, transition, which is a fade transition, and then we have balls dropping. After 10 seconds, we have a game over, and then we have the start game again. So if we click on start game, it should take us back to our game again. So looks like everything is working perfectly. Game over. Let's change the font color here to black. I think that would look better. You can change the font as well if you want. Start game. I don't like this transition, so I'm going to change it again in the future. Game over. In order for us to disable the gravity value on the cat node, we have to say cat node dot physics body dot affected by gravity, and then we can set that to false. So let's run this now. By doing this, that means our cat is not going to fall off the screen. You can see that our cat is there, our cat is doing well. But if we should collide with any of the ball, let's collide with the one of the ball, you can see that the cat now disappears. The reason why the cat disappears is because there's a collision between the two, and the dynamic property of the cat is set to true also by default. So that means our cat, when it collides with other objects, a force is applied to it, and the force of the ball moves the cat out of the screen. So what we do now is we need to set the dynamic property of the cat node to false. So we can say cat node dot physics body dot is dynamic. So we want to check if it's dynamic, and let's set that to false. Now let's run the code. So let's run the game and see where we are at. Okay, you can see now that the ball bounces off the cat. Now there's an interaction. Look at that. I can kick the ball away with the, so there's now a good interaction between our ball and our cat. They bounce off each other. However, the cat node, if you look at the cat node, you can see that the rectangle is not set correctly. Can you guess the reason why this is happening? The reason why this is happening is because the cat has the anchor point changed. So the anchor point was supposed to be at the center. Physics body is usually centered around the anchor point. And because we change the anchor point of the cat, instead of it to be in the center, we change it to be at the bottom left. So this is why the problem. So that means we need to modify the anchor point on the cat. You can see that we changed the anchor point on the cat here. So I'm going to delete this code by not changing the anchor point, and then I'm going to set the position of the cat instead. So I'm going to say cat node dot position, and that will be CG point. So I'm going to provide X and Y. We've already done this many times. Try and figure out what I'm trying to do here. So I'm going to say cat node dot size dot width divided by 2. So I'm setting the position, and then cat node dot size dot height divided by 2. So by not changing the anchor point, that means the rectangular physics body is going to be centered around the anchor point, which is going to be in the center, and our cat is still going to be positioned correctly. You can see that we're good. So now we have the cat and the ball interacting with each other because we set the dynamic to false. So that means our cat is not having any force applied to it, and it can collide with the ball, and also is not affected by gravity. I've created these basic diagrams just to explain what the difference between collision and contact is. If you think about a ball, for example, this green ball here, you can see that when this ball touches the ground, it bounces off and it continues to bounce. So this is a collision. So ball bouncing off the ground is a collision. When the ball collide with a cat and move in a different direction, that is a collision. A collision prevents objects from intersecting. So that means two objects, they will not intersect each other. When they come close in contact, they will bounce off each other. So that's exactly the behavior that we have in our game. That's what we saw in the last video, where when the ball touches our cat, the ball simply bounces off our cat. So that's collision, which is quite straightforward. And then we have contact. So contact basically is for us to be notified when two objects touch each other. Actually, let me go back. The collision between every object is by default set to true. So that means when you add multiple nodes into your app, multiple SKSprite node, they will all collide with one another because collision is set by default. If you look at what we did so far, I did not set any property for collision because all collision between every node are set to true by default. However, contact between objects, they are not set by default. Contact simply means that we want to be notified when two objects touch each other. Any kind of touching is a contact. So you want to know when two bodies have touched each other. You want to be notified. This is off by default. Whenever there is a contact between two objects, we're not informed in the app, and we have to write a code whenever we want to be notified that a contact has happened. For example, if two balls should touch each other, they should have a contact, we may want to set some kind of notification. Also, we may want to be notified when a ball has touched a cat. So even collision as well is a contact. So when the ball collide with a cat, that means it's made a contact. We may want to be notified for that. Finally, you can see that I have multiple balls here, which are colored differently. I have orange, red, blue, light blue, dark blue, and even green balls. So the categories can be used to specify which physics body group can collide with another group. This is kind of complex. So right now, our app is very simple. Our game is very simple. We have only two bodies. We have ball and we have cat. Let's say you have a complex game. For example, here now you can see that the red and the black ball, they can intersect. So that means when they gain contact with each other, they can pass through each other, they can intersect. Whereas the orange and the red ball, they are not allowed to intersect. If the orange ball touch the red ball, then they're going to bounce off. So this is where you have to use categories so that you can put all the black balls in one category. So category is basically to group all your objects in a simple way. So you can group all your red ball, like here now you can see that the red ball and a green ball also, they don't intersect. So they bounce off each other, so that means there's a collision. So the collision between the green and the red ball is set to true, whereas there is no collision between the black and the red ball. Also, the dark blue ball and the cat, there's a collision between them. So categories can be used to specify which physics body group can collide or make contact. So you set this group in your app to put all your physics body into different groups, and then you can manage that. You can decide which notification you want to receive when two bodies have contacted each other. Also, you want to decide if you want to make two bodies to be able to collide with one another, or if you don't want them to collide. There is a property called the bit mask property. There are three of them. The collision bit mask, it would define which category of physics body can collide with this physics body. So if you set a collision bit mask for a ball, so let's say you have a ball, and then you set the collision bit mask to that of a cat. So that means the ball can collide with a cat. So the collision bit mask defines which category of a physics body can collide with this physics body. And then we have the contact test bit mask. This defines which category of physics bodies causes intersection notification with this body. So that means if you set the contact test bit mask on a ball and you set it to a cat, so that means you'll be notified whenever the ball and the cat have intersected, whenever they've touched each other. Okay, and then the category bit mask, this one is quite straightforward. You're simply defining which categories this physics body belongs to. So when you set the category bit mask, you're saying that this red ball belongs to this group. So that's how you set the group. So you can have red ball category, blue ball category, orange ball category, cat category, and then you can set the category on them. All of this seems quite confusing, but they're quite straightforward. However, I'm not going to be touching on the complexity of this in this game because our game is very simple. We only have two bodies, and it's okay for everything to collide, and it's also okay to get a contact notification for everything. So because of that, I'm not going to be setting some of these properties, but at least by showing you exactly what they are, you're able to go and learn more about them. And some points to remember, I've already explained this to you, but I'm going to explain again. By default, collision between physics body is on by default. All bodies will collide until you set bit mask property to determine which body should collide. So by default, every node that you have in your game, they will collide with each other until you set the bit mask to decide which one should collide and which one should not collide. Also, by default, no contact notification is set. We are not informed of any contact until we set which contact we are interested in. So no contact notification until we set the contact test bit mask. And finally, there can be a maximum of 32 categories in your game. So plan carefully. So if you're going to have a lot of different sprite node in your app, and then you want to make sure that all of them belong to different categories. Keep in mind that you can only have 32 categories maximum in your game. So these are just the basic things that we'll cover, and then we're going to look in the next video how to actually use a little bit of this information. Like I said, I'm not going to be covering this in depth in the game because our game is very simple. What we need to do next is to conform to the SKPhysics contact delegate, which is a delegate protocol that allows us to detect contact between two physics bodies. So at the top here, after the SK scene, you want to put a command and then conform to the SKPhysics contact delegate. So by selecting that, if we command click on the SKPhysics contact delegate and jump to definition, you can see that we have the did begin and did end. So this is going to allow us, when the contact begin between two bodies, we are going to be notified. So let's go back. After you've done that, inside the did move function, we want to make sure that we make ourselves to be the delegate for this protocol. So we're going to say physics world dot contact delegate equals to self. So this is just a basic protocol implementation. You should be able to know how to do this. So physics world dot contact delegate is equals to self. So once we have that, then we now need to make sure that we conform to the did begin function. So if we type did begin, it says here called when two bodies first contact each other. Let's select that, and then inside here I'm just going to have a print statement, cat and ball contacted. Okay, so let's run the code to see if anything happens. Right now nothing is going to happen, and the reason why nothing will happen is, so let's see if we have a print statement. We need to remove we don't need to show the physics. You can see that when the ball and the cat contact each other, we do not have any notification, and the reason is because, like I said in the previous video, and the notifications are not set by default. What is set by default is the collision. So if we go back to the ball, what I want to do is I want to print two statements for you. I'm going to print the contact test bit mask and the collision bit mask. Ball dot physics body dot contact test bit mask, and then I'm going to print the ball dot physics body dot collision bit mask. So I'm going to print this value just to show you that for every node that you create, the contact test bit mask is not set, but the collision bit mask is set. So what this means is, let me start the game, and then we can see that, you see the contact for every ball that is being dropped, the contact test bit mask is 0 and the collision is set. So this means that the collision happens by default, but the contact doesn't happen. So what we want to do is we want to set the contact test bit mask so that it can inform us about every collision. What I'm going to do is I'm going to take a shortcut, which is going to mean that I'm going to say ball.physics body.contact test bit mask. I'm going to set it to the ball.physics body.collision bit mask. What that means is that we're going to be notified of every contact in our game. So this is complaining because it's an optional. So I'm going to force unwrap it because I am sure that the collision bitmap exists. So now if we run our game now, we should get the print statement inside this function, because now we say we want to be notified for every collision. So let's wait for the game to start. So let's test the first one. There you go, cat and ball contacted. Another one, and then another one. So we're going to be notified for every collision in our game now. So the step is quite easy. We have to conform to the SKPhysics contact delegate, and then we have to make this particular class to be the contact delegate by setting the physics world of contact delegate equals to self. And then we have to set the contact test bit mask. Remember that if in your own particular game you only want to be notified of certain contacts, then you have to create the categories and then make sure that the contact test bit mask is set to only the category, so that you can only be notified for that category and not for all. And then once you have that, you can conform to the did begin function, and then this is where we're going to be writing the code to actually detect the collision in our game. The first thing I want to show you is this contact object inside the did begin function, which is the SKPhysics contact. If we option click on the SKPhysics contact and then jump to definition, you can see that this object has body A, and body B. So that means for every SKPhysics contact object, we're going to get 2 SKPhysics body back. So, which makes sense. So if a ball touches the cat, then that means there are 2 objects. So we need to identify which of these objects is a ball and which of them is a cat so that we can remove the right one. The first thing we have to do is to set a name for the object so that we can identify it in our node. So for example, if I go to the ball, one property that we haven't talked about is the name property. So for every SK sprite node that you create, you can give it a name. So I'm going to say ball.name. So it's equals to, I'm just going to give it a simple name, which is ball. In fact, we can give our cat name as well, even though we don't need that. We can just say cat node.name equals to cat. So this is going to allow us to be able to identify from every children. Okay, so now back inside the did begin. So what I'll do is I need to be able to get the node A and node B. So I'll say guard let, because it's an optional, so I want to unwrap it. Node A equals to contact, so this SKPhysics object dot body A dot, this body A has another property called node, which is going to return the SK node back to us, else return. And then I'm going to do the same thing to get the node B equals to contact dot body B dot node, else return. So what we're doing right now is we're getting the 2 nodes that contacted each other, but we don't know if node A is the cat or if node B is the cat. So we need to find a way to figure that out. So the next thing now is to now check to see if node A name is the ball or if node B name is the ball. So that's very simple. We just have to say if node A dot name equals to ball, and then we can say print this is the ball, and let's use an else statement because it might not be node A that is the ball, it might be node B. Else if node B dot name equals to ball, and then we say print actually this is the ball. Okay, so let's run the code to see which of the body is a ball. Is it going to be the node A or node B? So let's see. Okay, the else statement is firing, so that means the else statement is the ball, but it doesn't really matter. We can still going to use the if and else statement. Okay, so now what we need to do is to remove the node from the parent. So that's very easy. We already done that before. So if node A dot name is equals to ball, we want to say node A dot remove from parent. And then if node B dot name is the ball, we want to say node B dot remove from parent. So let's run that. We should be able to remove the node from parent when it touches the cat. So that means we're able to identify the correct object to remove. You can see now, as soon as the contact, the ball is removed. So the game is working exactly as we intended. So what we want to do is we want to add a new node, which is going to be the score label. So I'm going to add it here. I'm going to say let score label equals to SK label node, and it's going to have a text, and the text is going to be a number 0 but in string, because the scores will be a 0 when the game starts. The next thing I want to do now is to add a small function, just like I did with the add ball and the add cat. This will be a small function that we can call add score label, and inside this function we're going to change the property. So I'm going to make sure that I don't forget to call it, because that happened to me many times. So now let's change some of the property of the score label. I'm going to change the font color, and I'm going to set it to .white, and then I'm going to also change the position, score label .position, and I'm going to put it at the center of the screen. So that will be CG point, and I'm going to set the X and Y just to be the half of the height and half of the width. So that will be self.size.width for the X divided by 2, and then self.size.height divided by 2 for the X. And then let's not forget to add it as a child, add child, and then we want to add the score label. Now that we've set this property and we've added it as a child, let's run the code to see exactly what the score label looks like. So start game, we can see that we have it there, 0, just right in the center. Okay, so the next thing we want to do now is we want to increase the scores every time the cat catches one of these balls. So let's do that. So I'm going to create a score variable at the top. So I'm going to go back here. I'm going to say var scores, and I'm going to set it to 0 when the game starts. And then every time there's a contact between the ball and the cat, we want to increase the value of the scores. So that means we have to use the did begin contact function at the bottom here. So inside the did begin contact, we want to change. We want to say scores plus equals to 1. So we want to add a value to the scores. And then we want to change the text on the score label dot text. We want to set it to the scores variable. So scores, and so let's run the game and see how that works. Start game, and we start at 0. So every time I catch a ball, it increases to 1. If I miss a ball, it shouldn't change. So there you go, 3. So our scores has been set, and then we can move on to the next step. In order to play sound in our game, we need the AV audio player class, which can be found inside the AV Foundation. So we need to import the AV Foundation framework. Once we import the AV Foundation framework, we need to create 2 variables. The first one is the audio player itself, and the second one is going to be a variable that track the game sound URL. So here I'm going to say var audio player is going to be an AV audio player, and I'm just going to initialize it. And then the second variable is going to be a game sound URL, which is going to be an optional URL for now. The next step is to drag the sound file into our project. So I'm going to go back to the Finder, and I'm going to drag the one that says sound.mp3. I'm going to drag into the project. Make sure you select the copy items if needed, create groups, and then select the target. Click on finish, and then we should have the sound.mp3 added to the project. Once the sound file is added to the project, the next step is now to set up the game sound URL inside the did move. Game sound URL equals to, then we want to check inside our bundle domain.url. So we want to say URL for resources with extension. This is a basic way to get access to any file that you need inside your bundle. So here we call it sound, and the extension is mp3. So we're simply saying we're looking for this sound file with the extension of mp3. So that's how we set up the game URL. So the next thing is to now create a simple function that allows us to initialize the sound to be played. So in order to do that, let's create a function, and then we call it init sound. It's going to be very simple. Don't let me forget to also call this here inside the did move init sound. Always remember to call your function. We need to set up the audio player inside of the init function and make it ready to play the sound. Because the game sound URL is optional, so we need to make sure that we have a game sound URL before we can do anything with it. So I'm going to use let URL equals to game sound URL, else I want to return. Okay, the next step is for us to set up the audio player. Audio player equals to AV audio player, and then that takes a URL, but because it throws, here it says throws, so that means we need to use a do catch statement. I'm going to pass in the URL, and then I'm going to put this inside a do catch statement, do, and then we want to paste that and then catch here, so that if there's any error, we can just print the error. And we need to now set the number of loops that we need. So audio player dot number of loops, this will tell you the number of times a sound will return to the beginning upon reaching the end. So we don't want this to be repeat, so we're going to set this to 1. And also we want to say audio player dot prepare to play. So the prepare to play will prepare the sound to be played. Here we need to say try, so we want to try it, and then inside the do catch statement we want to try it. So if it throws an error, we catch the error here. So once we've done that, the next step is now to play the sound whenever the cat catches the ball. So that means upon contact inside the did begin, here we want to say audio player dot play. That's simple. So this will play the sound whenever there's a contact between the cat and the ball. So let's run the game and then see what we have. Okay, the sound is playing. So let's quickly go through what we've done here. We imported the AV foundation and then created the audio player, which is used to play sound, and then the game URL just to get the URL of the sound.mp3 file. And then we create a small function, which here we check to make sure that a valid URL exists. And then we want to now set up our audio player. But in order to do that, we need to try to play the content of this URL using a do catch, so that if there's an error, we can do something else. Here we're just printing the errors, and then we want to tell the audio player to only play the sound once, and then we prepare the audio player to be ready to play. And then whenever there's a contact between the ball and the cat, we'll play it, and that's how we play sound in our game. Similar to what we did in the previous video, where we're playing the audio whenever there is a contact between the cat and the ball. Here we have to play the sound when the game starts. I will provide the link to the two sounds that I have used, so that in case you need any more sound, you can check out the website to find the resources where I got the sound from. What I'll do now is I'm going to create a new audio player, var music player equals to AV audio player, and I'm going to initialize it, and then I'm going to say var music URL, and that will also be an optional URL. So very similar to what we did previously. The next thing is to bring the music file into our game. So let me bring up the Finder, and we have the music.mp3 here, which you can find in the resources. So drag that into the game, and then now we want to set up the music URL. So just after we set the game URL, we can also do the same thing for music. URL equals to bundle.main.url for resources with extension. Here I'm going to call it music, and the extension is mp3. Very similar to what we did. In fact, the same thing that we did previously is what we're doing now, because now we need to create another. Here we have init sound. I'm going to create another function called init music, but rather than writing all of this function all over again, I'm just going to copy and paste. So I'm going to change this to music, init music, and let's call this function inside the did move. So let's call it here. And then we want to make sure we change all the variables. So here it's going to be music URL. The audio player will be the music player, and then also music player and music player. Okay. However, we need to make sure that the number of loops here is saying what's the number of loops that you need. You can set this to continuous loop by changing this property to -1. If you change the property to -1, we can jump to the definition. Here it says that any negative number will loop indefinitely until stopped. So that's why we put -1, so that it can continue to loop. And then because it's the music player, which means the file must be played immediately, so we have to call the play here. So music player.play. We prepare it for play, and then we play it immediately upon the game starting. So let's run the game to see how that works. As you can see, the game it's a little bit more fun. It's got some background sound. Maybe that's not your taste. You can always download a different sound file that you can use in your game. What we want to do in this video is to be able to mute the background music so that we don't have to listen to it, and then we can unmute it. So we're going to use two buttons that are placed on top of each other. So the first thing we want to do is to go to the assets folder and actually bring the A and the stop button into the asset catalog folder. So we have the play and the stop, and then we can go ahead and create the sprite node that we need. So let play sound node equals to sk sprite node, and it will take a name, and the name will be play. And then we do the same thing for stop. Let stop sound node equals to sk sprite node, and it's going to take an image named stop. Okay, so once we have these two sprite nodes, we want to add them to the game screen. So let's create another function that allows us to add the sounds node. So after the initialization of the music, I'm going to say func add sound nodes, and don't forget to call it. Okay, so let's go up here so that we can call the add sound nodes. So the first thing we want to set for the play sound. So play sound node, we want to set the anchor point. I'm going to change the anchor point to cgPoint.0, and then I'm going to set the position play sound node, the position, and that will be at the, I want to put it on the top left. So cgPoint, let's change the x and y value. So the x will be 0, and then the y will be self.size.height, and I'm going to subtract the height of the play sound node itself. That will be play sound node dot size dot height, and then let's add the node. So add child, so that will be play sound node. Because we want to add both the play and the stop node, we want to add it to the same position. So what I'll do, I will just copy and paste this and then change this one to stop sound node, and let me replace all the other occurrence of play sound node because we're adding them to the same position on the screen. We need to also set the Z position. So for the play sound node, I'm going to set the Z position to be a 4, and for the stop sound node, I'm going to set this Z position to be a 5. The reason is because I want the stop sound node to be at the top, so that one is the one I can click on when the sound is playing. Okay, so let's run the game. Okay, we don't have anything on the screen, so there must be a bug somewhere. Let's see. Oh yes, so here I said position. I said anchor point instead of position, so that's where the error is. I wrote anchor point twice. Let's stop the music. We're gonna bring the music back. For now, let's disable it. Okay, you can see this is too big for what we need, but you can see that it's been added to the top corner. So a quick fix for that is, let me stop the game. A quick fix for that is you drag these to the 3x because we're running it on the Super Retina display. Let's run the game because this will now be make it smaller. You should know how to use the asset catalog to manage your app resources. So that's smaller, exactly how we need it. The next thing we need to do is to add the ability to click on the stop and the play sound node. We've already done this in the past. We used the touches began. So let's go at the bottom here and add the touches began. So by using the touch began, we can identify which node we have touched at a particular location, and then we can perform some action. So let's get the location that is being touched. If let location equals to touches dot first dot location in node, and that will be a self, and then we want to now use this location. So then we want to check if at point, remember this this function will return an SK node back to you, so we want to check if at point the location that we touch, if that node equals to the stop sound node. So if we click on the stop sound node, what do we want to do? All we want to do in this position is we want to flip the Z position of the two nodes. So because at the moment the stop sound node, the Z position is 5, so we want to make that a 4. So that means it's going to go to the bottom, and then we want to change music. So music player dot pause. We want to pause that music. And then, does that make sense what we're doing? We also need to change the play sound node dot Z position. We have to change that to a 5. So that means that will go to the top. So when we click on pause, the play button shows. When we click on play, the pause button shows. And then we pause and play the music based on the one that we touch. And then we say else if at point, and then the location, if the node that is being returned is equals to the play sound node. Here we want to do the same thing. We want the stop sound node dot Z position. We want it to be 5, and then the play sound node dot Z position, we want that to be a 4, and then we want to say music player dot play. So we want to play the music. Let's give this a quick run, but before we do that, we need to play our music when the game starts. In a different game, you may want to put all of this functionality in a different screen called setting, but here I'm just adding it to the game screen. So let's start. You can see that when I click that, the music pause, and then we have the play button. So now I'm going to click on the play. So it looks like it's working exactly as we want. What we've done is quite simple. What we've done is created two nodes, and then we added the nodes at the top left corner of the screen. Set the Z position so that we have the stop sound on top of the play sound, and using the touches began function, we can flip the Z position so that we can change which nodes is showing at any one time, because you can also use the hidden property of it. You can hide and unhide the nodes, but I prefer to do it this way because it's more straightforward. So this is how we mute and unmute music in our game. There is a function called the update function that is called for every frame of the game. Let me show you. So if you override the update, just type update, and you can see this one that say update current time. So let's select this one, and inside here I'm just going to say print updated, and let's run the game. Before we do that, again I'm going to stop the music and let's run the game. So if we have 37 frames per second, that means this function is going to be called 37 times. You can see that it's been called a lot of times as our games is progressing, because it's called for every frame. Okay, so this is the function to use whenever you want to perform certain checks. So what we do now, I'm going to stop this. Let me stop the game and delete the print function. What we want to do is to check if the ball, the logic we're going to use to check if the game is over, is to see if the ball has crossed the bottom section of the screen. So we want to make sure that the ball position, the Y position of the ball, is less than 0. So if the Y position of the ball is less than 0, that means our ball has reached the bottom of the screen. That means the cat did not catch the ball. So that's the logic we're going to use. In order to do that, let's make sure that we've given our ball a name. Here we set the name for the ball. There's a way to find a particular node inside your game. So we can say let ball equals to self.child. You can see this one as a child node with name. So if we give it a name, it's going to return an SK node back to us. So I'm going to select that, and I'm going to say the name we are looking for is the ball. And here we want to cast it as SK sprite node. And because it's going to be an optional, so we can just use if let. And then inside of here, we want to check if the ball dot position dot y is less than 0. Here, then we can print a statement. We can say print the ball is out of the bottom screen. Let's do that and run the game. Okay, so right now I'm going to catch this one, but the second one I'm going to let it go out of the screen. You can see that it prints that statement. So that means the logic is working correctly. At the moment, we have a logic here, the one that is setting the game time so that the game ends after 10 seconds. So let's remove that. We don't need that. So first, let's delete the game time variable. We don't need the game time variable. And because of that, we can also delete the game time +1 here. And then finally, remember, every time the game is over, we invalidate the time and then we present the game over scene. We still want to do this, and then we want to delete this check. We don't need this particular check here. Okay, so now that means inside here is where we want to call this function. So if the ball position the Y should be less than 0, we want to invalidate the timer and then we want to present the game over scene. So let's run the game again and then see how our game works. So that means if the cat continue to catch the ball, we are never going to run out of gameplay. We continue to increase our score, and okay, in fact we can increase the timer, and that's part of the thing that you can add to your game. You can change the variable of the time the ball drops so that it varies. If I let the ball reaches the bottom, we have a game over. So this is how you use the update current time function to check a particular node. Here we're using the self.child node with name, which we cast an SK sprite node, and then we check the position of Y. If it's less than 0, then we present our game over scene. Saving a simple data type is quite straightforward. We're going to be using the user default class, which I'm sure you must have used many times. Let's go to the update function where we're going to be writing this code. So what we want to do is, before we call the present game over scene or invalidate, we want to save the scores. So we can simply say user defaults dot standard dot set. So we want to set a value for key. The value we want to save is an integer type. So, and that would be the scores variable. And then we want to give it a key. So I'm going to give the same name for the key, which is scores. That's all we need to do on the screen. So this means that whenever the game is over, we are saving the scores value. So then we need to go to the start scene where we're going to write a little bit of code. So let's add a function here, func add score label. So we're going to call this function inside the didMove function, which is at the top here. So we have the didMove function. So let's call the function, and then we're going to create the label. Let scores label equals to SKLabel node. You can initialize it without giving it any properties, and then we want to set some of the properties of this score label. So score label dot font size, I'm going to set that to 30, and then scores label dot position, I want to put it in the center of the screen. So that will be CG point, and for the X and Y will be self dot size dot width divided by 2, and the Y will be self dot size dot height divided by 2. And let's set the font name as well. Scores label dot font name, and I'll set that to Arial. And then let's set the font color. Scores label dot font color, I want that to be a black. And finally, let's add the label. That will be score label. If we run the code, we're not going to see anything because right now we don't set any text for that label. So the text we want to set is actually the user default value for the scores key. So let's say scores label dot text. That will be user defaults dot standard dot integer for key. So let's provide the key that we did previously, and that will be scores key. But because this is going to return an integer, but our text is a string, so we need to format the text like that, paste that inside. So now let's run the game and see what we have. It shows us 0, and the reason why it shows us 0 is because we haven't played any game. So, but let's add a text that says last score. So because we haven't played any game, we have it showing as 0. But as soon as we play a game, he's going to save it. So let's play a game. And in fact, we need to disable the show physics as well, so that we're not seeing the, okay. So we have score 3, 4, 5, 6, 7. So let's end the game. And if we should run the game again, we should see a 7. So last score was 7. So this is how you persist simple data in your game, such as integer, a simple string, using the user default class. This is where we stop in the last video. What we want to do is go back to the game scene. What we want to do is to go back to the add ball function and then modify this code so that we can also add a random ball. Before we do that, we need to bring in another asset. So let's go to the asset.exe catalog and then bring up the finder. So this is the danger ball. You can add any image that you want, but I like this ball. So I'm going to drop it there. I've named the ball a danger ball. And then let's go back to the start scene and modify the add ball function. The first thing we want to do is we want to generate a random number between 0 and 1. If the number that we generate is a 0, then we want to show the current ball. However, if it's a 1, then we're going to show the danger ball. So let's create a quick random value. So let random number is similar to this one. So what I'm going to do, I'm going to copy this code equals to this value. However, the upper bound will be 2. Remember, if you put 2, that means you're generating between 0 and 1. So the next thing is to actually modify this line where we're creating the red ball. I don't want to create the red ball. I want to create an empty ball. And then we want to use the if statement to check if random number equals to 0. So if it's 0, then we generate the red ball. Else, then we will generate the danger ball. So let's change this to danger ball. Okay. So what we're saying here is if the random number is 0, then we want to set the ball. Let's change this to var. Okay. Then we want to change the ball to the red ball, otherwise we change it to the danger ball. Okay, so let's run the code and see if that actually works. Start game. We can see that the danger ball is being generated right now, and then we have the other ball, the red ball. Okay, so that means our function is working correctly. Here we are able to generate a random number, and then we're using the random number to decide which ball we want to create. However, we should also change one property, and that will be the name. So here we're going to say ball.name equals to ball, and then here we want to say ball.name. Remember, we're going to use the name later to change some variables equals to danger ball. Okay, so that means we are free to delete the ball.name here, and then everything else remains the same. Let's run our game again to see if nothing has changed. Start game. We have the red ball. Now if we should collide, we should see that the behavior of the danger ball is different. In fact, danger ball can go out of the screen and the game is not going to be over. And the reason is because we're using the name property to check before we perform certain action. That is why the behavior of the danger ball is different from that of the red ball. Okay, so but as soon as the red ball goes to the bottom, the game should be over. Inside our add ball function, we use the skaction.sequence in the past, where we move the ball to the y equals to 0 position and then run a delete action on it. So that means the sequence takes an array of sk action. So what we want to do now is to create another sequence of action that will fade and then unfade the cat. Fading means to change the transparency. So basically you want to go from 1 to 0.1. So that means the cat is going to be completely transparent. And then we're going to change the fade back to 1. So from 1 to 0.1 and then from 0.1 back to 1. So we're going to run both action and then we're going to repeat that. So that's going to give some kind of blinking effect. So let's see how to do that in code. So let's create a function here. I'm going to say func and then add blink. So here I'm going to pass a node because I'm going to be calling this function and I want to pass the node that I want to blink into it. So the node is going to be an SK sprite node. And then so what I'm going to do is I'm going to create a fade action. Fade action equals to skaction.sequence. So because sequence takes an array of action, so what we want to do is we want to create a fade alpha. So we're going to say skaction dot fade alpha. So this fade alpha, there are two, by and there is 2. I'm going to select this one. So I want to fade it to 0.1 and I want to take a very little time. So that means it's going to be fast action. And then once I do that, I also need to create another sk action to fade it back to 1. So sk action dot fade to, so I want to change it back to 1.0. That's also going to take 0.1 second. So you can understand what we're doing here. We fade the alpha to 0.1 and then we fade it back to 1. Okay. So once we have the fade action, then we want to repeat it. So let's repeat action equals to sk action dot repeat. Remember the repeat also takes an sk action. And I want to repeat that 10 times because I don't want to repeat it forever, just a very short time. So I'm going to pass in the fade action and then I want to repeat that 10 times. So once we do that, then we can just say node.run. So we want to run this on a node and I'm going to pass the repeat action. It's quite straightforward. So now let's call this blink function when a cat touches any of the ball. It doesn't matter, we're going to modify the code later. So anytime there's a contact, we're calling the did begin. So here I want to say add blink and I'm going to pass in the cat node. Let's run the game to see if that works. Start game. In fact, you know what? I'm going to disable this physics. I think I've seen enough of the physics now. I'm going to just comment that out. So let's go back to the game scene and run the game. Okay, start game. So anytime the cat touches the ball, we should see the cat blinking. There you go, the cat is blinking. There you go. It will stop after a while. Let's play again. Blink, blink. The cat continues to blink, so there you go. You'll see that it will blink 10 times. So what we're doing is simply just fading the cat, fade out, and then fade back in. You can see that even the ball is at the bottom is touching our cat. We're going to fix that problem later. There you go. So our blinking effect is working correctly. So what we did is quite simple. Inside the add blink function, we faded the cat alpha from 1 to 0, which takes 0.1 seconds. And then we faded it back to a value of 1, which also takes 0.1 seconds. And then we repeated that action 10 times. And then we ran the repeat action on the node. So that's how you create a blink effect in your game. So we want to do is to add another variable for our game, which will track the number of lives the cat has. So var lives, and I will set that to 3. So we want to give the cat 3 lives by default. And then we want to create an SKLabel node to show the number of lives the cat has left on the screen. So let's create that. Let live label equals to SKLabel node, and we can give it a text of 3 as well, because by default it's going to show 3 on the screen. So once we have the live label, we need to create a function to add it. So after the init music, I'm going to create a small function to add the live labels. Func add lives label, and it's going to be a simple function. And here I'm just going to set the position lives label dot position equals to CG point. I'm going to give it a fixed value because I want it to be a fixed position at the bottom left. So I'm just going to give it X of 10 and Y of 5. And then I'm going to just add the child, add child, and I'm going to pass in the live label. Don't forget to now call your function. So I need to call this add lives label inside my did move. Okay, so let's run this to see exactly what we have currently. Start game, and we should see that we have 3 lives there. Okay, so that is working correctly. The next thing to do is to modify the did begin contact function so that whenever there is a contact between the cat and the small ball, the danger ball, then we reduce the number of lives and then display it on the screen. So let's go to the did begin contact function. Okay, so here we are simply just looking for the node that is named as ball. But remember that we have other nodes as well. First, let's remove this hard blink because this is not the correct place to call it. This is just for testing purpose. So what we need to do now is to create another to else if statement. So else if the node a dot name equals to danger ball, and then else if node b dot name equals to danger ball. So remember that here what we're doing is, let me quickly danger ball and also danger ball. So here I need to change this one to node A. So if node A equals to danger ball, so if there's a contact between the cat and any of the other physics body, we're checking. So here we're only checking for the ball, but now we want to check for the danger ball. So what we want to do is here, even though when there's a contact, we're going to remove the danger ball as well, and then we're going to add a blink, add blink. And here we're going to pass the cat node, and then finally we're going to reduce the number of lives. So lives minus equals to 1. So we're subtracting 1 from the live label. So let's do the same thing here. We're going to say add blink cat node, and also lives minus equals to 1. So once we remove 1 from the lives, we need to display the current value back on the live label. So we can say live label dot text equals to, and then we want to pass in the lives. So let's run the game and see exactly what we have. Normally when we touch the danger ball, we should have the live reduced, but we shouldn't have the score increase. But as you can see, the scores is also increasing, and so which is not correct. So that means there's a bug in our code. So let's find it. So I'm going to stop the game And this is the bug. You can see here that outside the if else function, we're increasing the score regardless of which of the ball is being touched. So I'm going to take that code out from there, and I'm going to put it where it's supposed to be. Only if the node that is being made contact with the cat is a ball, that's when we increase the score. Otherwise, we blink the cat and then we reduce the life. So let's run the code again. The score should not increase when we touch the danger ball, but when we touch the red ball, the score should increase. However, if we touch the danger ball, the life should reduce. Okay, so let's touch there you go. We have our scores increasing, but it doesn't affect our life. But as soon as we touch the danger ball, that should reduce the life count. Now we have 0. Now it's gone to -1, so that means we have another bug. We shouldn't go past 0. Okay, so in the next video, we're going to be fixing that bug, but now the game is looking good. Previously in our game, we can see that it is possible for the lives to go to -3 or -4. We don't want the life count to go below 0. The reason why the life count go below 0 is because currently we are only checking inside the update function for the ball or position .y to be less than 0 before we terminate our game. What we want to do is to end the game if the number of life is also equals to 0. So we can add a new check here. We can say if lives equals to 0, and then we want to do this exact function. So because I don't want to copy and paste code, so what I'm going to do is I'm going to take this code out, and I'm going to create a new function called func. I'm going to call it end game. Okay, and inside this function, I'm going to paste this code. So whenever the game ends, we want to save the score. We want to invalidate the timer and then present the game over scene. So I'm going to call this function. I'm going to call it here. We can delete this now, and then I'm going to call that same function here as well. So that means if the life equals to 0, we end the game, or if the ball or position y is less than 0, we also end the game. So let's run the code and see what we have. So okay, so touching these balls should reduce the life count. That should increase the scores. Let me touch it again. If I should touch this one now, the game should be over. So our function is working exactly how we want it. Okay, let's try again. Life count should reduce. The score should increase when I touch the red ball. Okay, danger ball, game over. Okay, so the function is working correctly. The final thing we need to do is, let me show you another bug that is currently in our code. So if I should start the game, if I avoid the danger ball, when it reaches the bottom, if I should go back there, you see the cat blinked, and the reason is because we need to remove the danger ball from our game as soon as possible when it reaches the bottom. So that means we need to perform the same checks that we did here. So here we're saying if let ball, so we need to do the same. If let ball equals to self dot child node with name, and we want to pass the name. Remember, the name is danger ball. We want to cast it as SK sprite node, and then what we do is quite simple here. So if ball dot position dot y is less than 0, we want to just ball dot remove from parent. So let's run the game and see if we still get the same bug. Okay, so let's try. I'm going to avoid it, and then I'm going to move it immediately there. You see now it doesn't blink if I move it immediately because the ball is removed from our screen as soon as the ball reaches the bottom. So let's try again. I'm going to avoid it and immediately move there. So there's no effect. So the bug has been removed from the game. So our game is working exactly how we intend. The web tool that we're going to be using is called canva.com. So if you go to canva.com, if you don't have an account already, you can sign up on this screen. I already have an account, so I'm simply going to log in. Let me log into my account. Straight away, you can see that some of the graphics I've used in this course, for example, this one, and then this one, and then the cat itself, and this one, even the start button, most of them are created from canva.com. You can see some of the templates here at the top. I'm going to pretend I want to create a new game button. So what I will do is I will go here and say use custom
dimension. If you want to create from a template, you can click on create new design here, which is going to show you all the templates that are available. But if you want to create something like a custom, I'm going to select use custom dimension. You can provide the width. I'm going to say 400 pixel by 100 pixel, and I'm going to select design. Here you can go to the background and you can select any color you want for the background. So if you want our button to be this color, we can even select any of these pre-designed background, so you can have a cool background for your game. You can see we have so many options, so feel free to choose whichever. I like this one, it's really nice. Some of them has amount on it. For example, this one is $1, which means it's not free to use, but all the ones that say free, you can use them for free. Let's go back. I'm going to select this color again, and I'm going to select the text option on the side here, and you can have any of these pre-designed text. I'm going to select this one that says stick night, and it's going to be automatically added to the background. So let's delete some of the options that we don't need. I don't need this one at the top. So if I click on it, you have this option here. If I click on the bin icon, I can delete this element or the entire group. So I'm just going to delete the element. Same thing for the one at the bottom here. I'm going to delete that element, and then I'm going to increase the size for this. Okay, you can drag, we can say end game. As simple as that, we designed a button for our game. So this is how easy it is for you to design things. Play around. You can use the elements as well. If you want to create a new page, you can click on this icon to duplicate this page, or you can just say add page. So now you say I have a page. You can add grids if you want grids, and if you want frames, shapes, usually I use that. For example, our balls, I use this for some of our balls, and I just change the background. For example, I can change the background of this to orange, and then I can add a new one and drag it to this. So you can see this is really cool, but I'm not here for this. I'm here to actually design the icon that we need for our game. So let me close this page and go back again. And here I'm going to use the custom dimension again, but the size that I want is 1024 by 1024. So this is the size of the icons that you have to use on iTunes Connect. So make sure you create an app icon of this size and then click on design. Now that the page is opened, let me go to my uploads. The upload is the area where you can upload your own image to. I have the cat image here. I've already uploaded it to Canva. So I'm just going to simply click on it, and it's going to put it at the center of the square. So I'm going to enlarge the image by dragging on the corner. It's quite blurry now because the cat image is not high quality, but don't worry about that now. So I'm just going to drag it to the vertical and horizontal center, and we have a guide to help us to know when we are in the vertical and the horizontal center. So I'm going to drop it there, and that's all I need. You can be as creative as you want. For example, if you want to add like a ball, I can simply go to the shapes and add a small ball there, and change the color to a red. Let's select other colors, so I can make it red. So now the ball is red, and I can possibly, just to make it look like a cat is playing with a ball. I'm not going to get any fancy. I'm just going to use this basic icon. So what I'm going to do is, once you're finished with your design, simply click on download at the top. Then you can select the file type you want. If you want it in PDF, if you want it in JPEG or PNG. So I'm going to use the PNG, which is recommended, and I'm going to click on download. We're going to be using this downloaded image as the app icon. We're going to be using it for the launch screen, and we're also going to upload it to the iTunes Connect website, which is why it is important for you to make sure that this icon is 1024 by 1024. Without a launch screen in our project, Xcode will not allow us to upload this project to iTunes Connect. In order to create a launch screen, we can use the launch screen storyboard that is automatically added to every project that we create. If you click on the launch screen.storyboard in the project navigator, select it. This is the launch screen storyboard. We're going to customize this a little bit, but before we do that, we need to drag the image that we're going to be using into our project. So select the asset.xc asset and then bring up the finder. Here I'm going to drag the icon that I need here. So I have the icon, the one that we created in the previous video. So now let's go back to the launch screen storyboard, and then we need an image view. So search for the image view. drag one onto the vertical and horizontal center. Okay, so I'm going to make it a perfect square. So I'm going to set this to be 250 by 250. And let me drag it again to the vertical and horizontal center. I'm going to set the constraint on this. I'm going to set the width and the height to be fixed. And I'm going to place it in the horizontal and vertical center of the container. Okay, so now that is set, I can go to the attribute inspector and change the image to the large icon, or I think it's called icon large. Okay, that's it. So now we have our cat. Set the content mode to aspect fit. So now we have the launch screen set with a very basic image. If you want, you can put a name at the bottom here using the label. You can also design the screen as much as you want. Let's run our game to see what the launch screen looks like. Sometimes the launch screen will come up so quickly, so you may not get a chance to see it. There you go. That's our launch screen. So it's looking great. Let's try that again. This time it's going to be very fast, so pay attention. We may not get to see. Yeah, that's our launch screen. Let's try it again. Okay. Because the launch screen comes up really fast, there is one simple hack that you can use to delay the launch screen so that you can see it for a prolonged period of time. So if you go to your app delegate and then inside the did finish launching with option, inside this first function at the top here, if you type sleep and then pass in a value, for example, let's say 5 seconds or even 10 seconds, what will happen is if you run your code, that means this function is going to pause the entire application for 10 seconds, which means you're going to see your game for a long period of time. So that means this is going to show for 10 seconds. Even though you shouldn't publish your app with this sleep function, Apple might reject it, but it's a way for you to see your launch screen for a much longer time, especially during the time that you're developing your launch screen and then you want to see exactly how it's looking. Because the launch screen comes up so fast, you may want to delay the time. So if you delay this, for example, 3 seconds, that means your launch screen is going to be shown for 3 seconds before it disappears to the home screen. There you go, 1, 2, 3, and then you should go back to the home screen. So that's a simple hack, but remember to remove this before you publish your app to the App Store. Go to the App Store app, which is the app that you can see here, the one that says App Store. Launch it, and once we're on that, I want you to type inside the site here, type asset catalog. You can see the suggestion, the one that says asset catalog creator. Select that. It's called the asset catalog creator. So select it, the free version. This is what we're going to be using. From this screenshot, you can see that there are so many icons that are required in order for us to publish our game. The reason is because different icons are shown for different things. For example, for the push notification icon is very small. It's a different icon that is used. For the icon that you can see on the home screen, a different icon size is used. For icons that is shown when you do a spotlight search, the icon size is different as well. So we have different icon sizes that are used for different things in our iPhone. So what we need to do is we need to click on install. It should automatically install, or it can ask you for your credentials. Just provide your username and your password. If you're already familiar with using photo editing software like Photoshop, you can generate all these icons, but I am not particularly good at any of this photo editing software. This is why I'm using a simple tool like this to help me to generate all the icon sizes that I need in order to publish my app. So the next thing is to open the asset catalog image creator. So what you need to do is bring up the finder and then drag the icon that we created previously. If this is the first time you're using the asset catalog creator, it's going to ask you for the output directory, which means that the icons that are generated, where do you want them to be located? I'm going to set my desktop to be the output directory. So set as output directory, and it's saying multiple existing asset catalog found. I'm just going to say create new. Select app icon under iOS and then set your project folder where you want the output result to be. Then click on create asset catalog, and as you can see, it's been added to our desktop. So I'm going to click on this just to see exactly what is generated. You can see that it's generated all of these different icon sizes. So now let's go back to our Xcode. This is where we stopped the last time, and I'm going to bring the finder up again. Go back to where the asset was added. If you look in our game, you can see that we already have asset.exe asset. and this one is also called assets.xc asset. Because of the clash of the name, it's not going to work if we drag it to our project. So what I need to do is I'm going to rename this one to be icons.xc asset, and then I'm going to drag that to our project. Click on finish, and we have the icons added. Let's click on that to see what has been created. You can see that we have these different icon sizes: 20 point, 29 point, 40 point, 57 point. You can use the photo editing software to do all of this, but I prefer to use this way. So the next step is to tell our project where to find the icons from. So what to do is want to click on this blue icon, the one at the top here, under the project navigator. So click on it. At the bottom where it says app icons and launch image, our app icon source, we want to change that. Currently is pointing to the asset catalog. You can see the one that's graded says asset, but we want to change this. Remember, all our assets is inside the icons folder, so we want to select this one instead. So we want to select the app icon under the icons folder. Okay, let's select that, and then before we run our app, let me bring up the simulator to show you what the icon currently looks like. So the icon currently looks like this, but if I should run the project now, let's run the project, we should see a different app icon. Let's go back home. You can see now that we have our icon looking exactly how we want it. It's very clean with white background and a little cat. So if we click on it now, you can see that it's nice. One thing you should always keep in mind is you should always have a good transition between your icon to the launch screen to the game. So that's a cat on our app icon. Our launch screen is also a cat, and then the final game we have a rotating cat. So let's try. You can see from that to this to that. So we have a nice transition from the icon of white and orange color to the launch screen, which is also white and orange color, to the final start screen, which is also white and orange color, all of them showing the cat. So that's a nice transition you should always try to achieve in your game. So this is how you add app icons to your game. The first thing we have to do is to create an app ID on the Apple developer website. So if you go to the developer.apple.com website, this is the landing page. You want to click on the account. I've already logged in. If you haven't logged in, he's going to ask you for your email and password. Provide that. Here you can see where it says certificate, identifiers, and profile. So select that option, or you can select it from the left hand side here. What we want to create is a new app ID. So if you click on the app IDs on the left here, and then click on the plus at the top here to add a new app identifier. This app identifier is required to be created first. If you don't create this app identifier first, you will not be able to create a new app on iTunes Connect in order to submit your app for review. So now we are on the Register iOS App ID screen. You can give your game any name. So I'm going to call this one Cat Game. And then here you need to provide an explicit app ID. You said this string should match the bundle ID of your app. So let's go back to the project, Xcode project, and go back to our project at the top. The bundle identifier that we use here is netoptimist.gameapp. Yours might be different. Simply copy it, and then let's go back to the Apple developer website and paste it where it says bundle ID, and then scroll to the bottom. Don't change any of the options here. Click on continue, and the reason might be because I already registered it in the past. So what I'm going to do is I'm going to change it. So I'm going to say GameApp 2, and I'm going to click on continue, and it's accepted it. So click on register to register that ID. Here it says the registration is complete. So I'm going to click on done. But more importantly, because the cat game is now using the game app 2 instead of the game app, let's go back to our Xcode, and I'm going to change this one to game app 2 as well, because they have to match. If they don't match, then it's not going to work. So now we have the bundle identifier of our game is the same thing as the bundle identifier created on developer.apple.com's website. The next step is to go to the iTunes Connect website. If you go back to the Apple developer website and go to the account, you have the access to go to the App Store Connect. So if you click on the App Store Connect link here, it will take you to the iTunes Connect website. So here you can see where it says My Apps. Click on My Apps. It's going to show you all the apps that you have. So these are all my apps here. In order to create a new app, simply click on the plus icon here. So I'm going to click on that, and select New App. Here you want to select the platform to be iOS, and then the name of the app, let's call it Cat Game App. It's going to ask you for the primary language. I'm going to select English UK, and the bundle ID. If you didn't create this one previously on the Apple developers website, then you will not see anything here. But because we already created one, we are able to select the game app. You can see the cat game, which is required. Select the cat game which we created previously. That is why the previous step is important. The SKView is a unique ID for your app that is not visible on the App Store. So I'm going to provide 1, 2, 3, 4 here. This is optional. You don't have to touch this, and then click on create. So that means we now have our cat game app set up, which means it's now ready for us to upload our project from Xcode to iTunes Connect website. If you haven't already added a theme to your Xcode project under the sign in section, here it says Optimist Limited, which is my own theme. So what you want to do is you want to go to Xcode Preferences, and then under account, you want to add a new account. So if you haven't already added your credentials to Xcode, you want to click on the plus button here and then select an Apple ID, click on continue, and then provide an Apple ID and a password. So that way you will have a theme added to the Xcode project. This is an essential step before you can upload your game to iTunes Connect. The next step is to upload the game. If you go to the top here where you see the simulator, if you click on it and scroll all the way up, you will see this option that says generic iOS device. You can either select your own device or one of these generic iOS device, then go to the product and then click on archive. This is going to archive the game and it's going to make it ready for upload. So we need to wait for the next window. It might ask you for your computer password. Simply provide it. And I'm going to select always allow. Here we have the archive that is ready to be uploaded, and you can simply just click on this button that says upload to App Store. So I'm going to click on this button and it's going to do a lot of check-ins and fetching and preparation for us. I'm going to leave all the options here selected and I'm going to click on next. Automatically manage signing, that is fine. Click on next. So it's now communicating with Apple. If everything goes well, we should be ready to upload. It's asking for the password again, so let's provide that. So I'm just going to click on upload and it's going to talk to the iTunes Connect, make sure that everything is okay, and then it's going to upload the app to iTunes Connect. So let's wait for the upload to finish. So now it says upload successful. So we have successfully uploaded our game to iTunes Connect. We can quickly check the status of this upload. So what we need to do is let's go back to iTunes Connect. So this is the cat game app that we create. If you go to the tab where it says activity here, click on that. You can see that it says processing. So it's going to process the build. Let's go back and look at some of the information that you need. Before you can submit your app, you need to provide certain information. If you're collecting users' information, then you must provide the privacy policy URL. In our game, we're not collecting any user information, so that's going to be optional. You have to provide your app title. You need to provide the category. This is not optional. So for example, our own is game. So we have to provide that category. Let's look at other option, pricing and availability. Let's save this information. If we go to the pricing and availability tab, you have to select if you want to make your app to be free or if you want it to be paid. And none of these other options is important. But the most important tab is this one that says prepare for submission. So let's save it again. If we go to the prepare for submission page, this is where we have to provide a lot of information. You have to create screenshots for different devices. So if you support iPad, then you have to provide screenshots for the iPad as well. So you can read some of these guidelines to show you how to create some of the information that is required. You have to provide the description text and then the keyword that people are going to use to find your app, the support URL, so you need to provide a website where people can get support for the app. The next important thing is the build section here. You cannot submit an app for review until you select a build, and for you to select a build, you need to wait for the build that is being processed to be completed. Once that build is completed, then you'll be able to select that build here. Before you can submit any app for review, you need to attach one of the builds, and the one that we currently have is being processed. And then the next step for you is to provide an App Store icon. The icon that we created before, which is the 1024 by 1024 icon, that is the one that is required. Provide the copyright information, provide first name and last name, and then the address, phone number, and email. All these are required. And then you have to provide contact information just in case the review requires to contact you. So these are all the informations that you need to provide before you can submit your app for review. If you click on save and if you click on submit for review, it's going to tell you all the things that are required by marking them in red. So you can see that all the fields that are marked in red are required. Okay, so let's go back to the activity page to see if it's still processing. You can see that the icon is showing it's still processing. Once the processing is completed, you'll be able to select that build here. You can go ahead and fill out all the other information and then submit the app for review.